Hello students, let us discuss about structure of Borosol. So as we have told in preparations properties, Borosol is also known as inorganic benzene. So the structure is also same like this. Okay. So how we are getting double bonds Borosol here? The double bonds is due to lone pair of electrons. If you turn lone pair of electrons, automatically we are getting a structure like this. Based on double bonds only, we are getting a Borosol structure, that is BH NH double bond NH. Why? Because lone pair of electrons we turn here, double bond BH NH double bond BH. So this is the structure we have got, okay, due to the presence of turning of double bonds. So now let us enter into the structure of Borosol. So generally here, according to X-ray crystallography, has shown that boron and nitrogen atoms in Borosol are arranged in planar hexagonal ring, which is having bond length between boron and nitrogen is 1.47. Okay, so what we can say, according to X-ray crystallography, has shown that the boron nitrogen atoms in Borosol are arranged in a planar hexagonal ring, we can say. Which boron nitrogen bond length is 1.47 angstroms. Okay, so what the X-ray crystallography has revealed, if you have been seen here, boron and nitrogen, this is a Borosol structure which is arranged in a planar hexagonal ring. So in which these two, if you take, has been taken these two, it is having bond length 1.47. These two, if you have been taken, means each BN is having bond length 1.47 angstroms. Coming to electron diffraction studies. So electron diffraction, what it has told? So what about electron diffraction data has confirmed? So electron diffraction says that Borosol has a similar structure with benzene. If you have been taken benzene, the structure is same. Yes or no? So what is the bond length? With BN bond length 1.44 angstroms and bond angle will be 120 degrees, we can say. So means what? Here also 1.47, almost the bond length is same. Coming to bond angle, why we are saying bond angle? Because here it is sp2 hybridized. Okay, so like benzene, it is also sp2 hybridized and it is having bond angle 120 degrees. So the bond distance between the single, so the single bond distance is 1.54 angstroms and double bond distance is 1.36 angstroms, like benzene ring. So here the structure may be represented as like this, as we have studied. So here for single bonds, what is the bond length we are having? For single bond we are having 1.54 angstroms and for double bond we are having 1.36 angstroms we are having. Okay, so the extra electron pair, so whatever extra electron pair is present in nitrogen atom, so because of this only, by rotating means, which will give negative charge and positive charge, means electronegative atoms, how we are giving formal negative and formal positive, same thing it is going to happen. If you break the bond here, here positive, here negative you are getting. So means what, here due to the presence of lone pair turning only, we are getting a double bonds here. Okay, so means the formal charge on negative and boron and formal positive charge on nitrogen atom will give the structure of this. So generally the resonance structure, so when you write the resonance structure, so the resonance structure, how we are getting, only two structures we are getting, that is double bond NH, NH, B, double bond NH, here H, double bond B, H. So this is one of the structure. So resonance structures are indicated by an arrow, double headed arrow. So another structure we can write it as like this. When you turn lone pair of electrons, so you are getting like this, BH, NH, double bond NH, sorry, BH. Okay, so this is the structure we are getting in Borosol, so which is the resonance structure of this. Okay, so the difference is that what, here in Borosol the pi bonding is day 2 and it will form overlapping of empty p orbitals of boron filled with p orbitals of nitrogen. Okay, so here let us discuss according to molecular orbital theory. So here we can say that is general structure according to extracrystallography, according to electron diffraction we have discussed. So what we have said, that the difference, what is the difference here in Borosol, the pi bonding. So whatever the pi bond is getting, means if you have been observed between the boron and nitrogen, we are having pi bond. So the pi bonding is day 2. Day 2 is nothing but here what, coordinate covalent bond. Okay, so means what, empty p orbitals of boron was filled with nitrogen. Filled p orbitals of nitrogen is filled with empty p orbitals of boron. So that's why we got that boron structure. So according to here, let us take here boron diagram. Nitrogen, boron, so here nitrogen. Okay, so this is the structure. H. Okay, so now let us see here. So this is the p orbitals we have been drawn here. So here let us join I'll explain you clearly about this one. Okay. So now let us fill these atoms. Okay, so now let us start. So this is the molecular orbital diagram of the Borosol. Okay, so here generally the molecular orbital description of Borosol to form pi bond and sigma bonds in the ring. Okay, it will form molecular orbital. What happens in Borosol? It will form, according to molecular orbital theory, the Borosol will form pi and sigma bonds in the ring. So because of the difference in the electronegativity between boron and nitrogen, so here the pi orbital in Borosol is more with high electronegativity nitrogen than with boron. So here what we can say here, the electronegativity difference between nitrogen and boron is that the pi cloud in Borosol is more with highly electronegative nitrogen than with boron. So means what here, what is the means we are seeing here the difference between, means here it will be getting partially negative, partially positive charges. Okay, so whenever it is getting here the pi bonding in the ring, so the partial, what happens, the pi bonding decreases the ring, means it weakens the ring. So whenever nitrogen added some of the basic character it is having, how the it is an acidic character, this is the basic character. So nitrogen will be having what here, basic character. Coming to boron, what we are having, acidic character. So means what here, due to the presence of the nitrogen basic character and the boron acidic character. So here let us take polar compounds. Polar compounds means what, different molecules we are taking HCl. So what happens, this HCl attack the double bond between nitrogen and boron. Yes or no? If you have been seen the properties. So the different electronegativities of boron and nitrogen, whatever you are taking here, what will happen, it will stabilize, and boron by electronegative substituents and to nitrogen will be electropositive substituents. Okay, so that's why like benzene only Borosol undergoes addition reactions, we can say. Why it is taking boron electro negative and it is taking electropositive, means due to the presence of acidic and basic character. So when you have been observed the properties in the previous class, the Cl minus is going to attack, means the electronegative atoms is going to add in the boron and positive atoms is going to add in the nitrogen. Why it is going to happen? Why? Because due to the pi electrons weakens the boron, pi bonding will be very less in boron nitrogen bonds due to the electronegativity. So here the delocalization of electrons in pi orbitals have been taken similarly like benzene. Why it is taken? Due to the presence of lone pair of electrons. Okay, the 6 electrons in the pi orbitals and 3 nitrogen atoms, not each from 6 atoms. So here 3 electrons. So here what we can say here, one is filled orbital, another one is empty orbital. So means what? The filled orbital is overlapping with the empty orbital. So this is the way, that's why here the delocalization of electrons is going to take place. How it is the delocalization? So this is the filled orbital and empty orbital only taking delocalization of electrons. So because of this reason, so according to this only we have been explained the structure of the Borosole. So this is about molecular orbital structure of Borosole. So in the next class we can start 14th group elements. Thank you.